Welcome to Deep Tech Dharma, an autonomy thesis. So I want you to just take a second and imagine the Indian Ocean.
Yeah, it is a massive, massive space.
Right. It's this massive, completely silent expanse of water. And somewhere, maybe 300 meters down, there is this 20-ton steel machine just gliding through the dark.
Completely undetected.
Exactly. There's no crew on board, no oxygen tanks. It has just been down there listening for 40 days straight. And the craziest part, the software running its brain was written by a startup with less than $5 million in the bank.
Which is just, unheard of in defense tech.
It really is. So our mission for today's deep dive is to understand how a relatively unknown company called Rekise Marine is basically building India's robot navy. Because the future of the deep sea is, well, it's incredibly quiet, completely invisible, and entirely crewless.
And that shift, moving from human endurance to machine persistence, it honestly changes the entire math of naval defense.
Ah.
Well, breaking foreign dependency in the deep sea is rapidly becoming, absolutely critical for national sovereignty. And to understand why that is, you really have to look at the geography of the Indian Ocean region.
Right, which is huge.
It's enormous. It stretches from the Strait of Hormuz in the west all the way over to the Malacca Strait in the east. And over the last several years, there has been this relentless growth in Chinese naval activity and specifically the presence of survey vessels in these waters.
Yeah, our sources mention these survey vessels are out there mapping the ocean floor. But I have to imagine it goes far deeper than just, drawing topological maps, right?
Yeah.
They're looking for an operational advantage.
Oh, absolutely. They are mapping the operational battle space. It goes way beyond just topography. They are measuring salinity levels, they are tracking shifting thermal currents, and crucially, they are mapping thermoclines.
Wait, thermoclines, break that down a bit.
Right, so thermoclines are basically layers of water with drastically different temperatures. And in submarine warfare, sound is everything. You literally navigate by sound.
Right, because you can't see anything down there.
Exactly. But a thermocline can actually bounce or bend a sonar wave. So if you know exactly where those temperature layers are, you essentially have the literal map required to park a submarine so it remains acoustically invisible to surface ships.
Oh, wow. So whoever has the best data on the water column essentially owns the stealth advantage in that ocean,
That is exactly it.
which obviously puts the Indian Navy in a very tough spot. You have this incredibly vast, constantly shifting environment to monitor.
And the harsh reality of naval economics dictates that you just cannot simply build enough traditional manned submarines to cover all that territory.
Because it's just too expensive.
Yeah, manned submarines are marvels of engineering, but they cost billions of dollars each. They take a decade to build. Every single time you deploy one on a routine surveillance mission, you are committing a highly scarce strategic asset.
Not to mention risking dozens of human lives.
Right, just to sit and listen in one patch of ocean.
It's like trying to guard a sprawling thousands of acres estate using only one or two extremely expensive security guards. These simply can't be everywhere.
Right, they get exhausted.
Yeah, and if they're at the front gate, the back fence is wide open. So the historical alternative for a lot of nations has been to look outward, like to import unmanned systems from other countries to fill those surveillance gaps.
Which introduces an intolerable strategic risk, especially for a nuclear power.
Because of the data.
Exactly. Think about what an unmanned surveillance submarine actually does. It swims around your most sensitive coastal waters, mapping the exact same topography and thermoclines we just discussed.
Right.
It records the acoustic signatures of your own ships. So if you import that system, foreign-written software is touching your nation's most sensitive naval data.
That is a massive vulnerability. In a domain as secretive as undersea warfare, you absolutely cannot have a foreign backdoor into your data pipeline. You just can't rely on a black box that you didn't code yourself.
No, you can't. And that strategic imperative really leaves only one viable path, which is domestic development. You have to build the hardware, and more importantly, you have to write the code yourself.
Which brings us to Rekise Marine.
Yes.
Founded in 2017, led by their CEO, Mitrai Maka. And their flagship platform is called Jelkapi. Now, I am looking at the dimensions in our notes here, and calling this thing an underwater drone, it feels completely inadequate.
It really is a misnomer.
Right. 20 tons, 11 meters long, 2 meters in diameter. That is not a drone. That is a small ship.
Yeah, officially, Jelkapi is classified as an extra-large autonomous underwater vehicle, or XLAUV. It is the largest and most complex unmanned underwater platform in India's defense ecosystem right now.
And it can go down to 300 meters, right?
Exactly, capable of operating at depths of 300 meters. But the raw size isn't really the primary engineering marvel here. The real breakthrough is how it solves that persistent surveillance problem.
Which brings us to the endurance factor. The notes say this thing can stay out there for 45 days. And I have to ask the obvious mechanical question here.
Go for it.
If it's running on batteries, how does it stay deployed for a month and a half without a single human intervening? Like, my phone barely lasts a day.
Right, so it relies on an autonomous surface recharge dive cycle.
Okay, what does that mean?
Well, Jalcopy does not rely solely on its lithium-ion battery pack for the entire 45 days. It actually carries an onboard diesel generator.
Oh, interesting.
Yeah, so it runs its surveillance mission deep underwater on the batteries, completely silent. But when the power runs low, the vehicle's autonomy engine calculates the safest time and location to surface.
So it brings itself up.
Exactly. It breaches the water, activates the diesel generator, breathes in atmospheric air to run the engine, recharges its own battery banks, and then dives right back down to resume its patrol.
Wait, hold on. Lithium-ion batteries.
Hmm.
We're talking about putting massive banks of the exact same volatile battery chemistry that powers electric cars inside a sealed steel tube
Mm-hmm.
under immense hydrostatic pressure.
Yes.
That sounds like an absolute engineering nightmare.
It is incredibly dangerous if it's not managed perfectly. I mean,
Yeah.
in a traditional manned submarine, a battery fire is literally one of the most catastrophic events imaginable.
Right, because there's nowhere to go.
Exactly. Now, by removing the human crew, you do remove the life support constraints, but you still have to design these highly advanced battery management systems. You have to prevent thermal runaway while Jalcopy is operating deep in the water column.
And then it has to run that surface recharge dive cycle you mentioned. But how does it know when it's safe to surface? I mean, it can't just pop up in the middle of a commercial shipping lane.
No, it can't. The autonomy engine is constantly calculating multiple variables. It tracks its own power depletion curves, cross-references its location with known commercial shipping lanes, and uses its sensors to make sure no hostile vessels are nearby before it initiates the surfacing sequence.
So it literally sneaks up to the surface to breathe.
It does. And while it's underwater, it operates as this unblinking robotic eye and ear.
Right. The sensor payload.
Yeah, the payload includes electro-optical and infrared cameras, multi-beam echo sounders for high-resolution seabed mapping, and of course, passive sonar arrays.
But, a blind piece of steel in the ocean is completely useless without the intelligence to process what those sensors are actually picking up.
Exactly.
The sources emphasize that while the hardware is impressive, the hull is just steel. The real value of Rekise Marine is the code inside.
That is the crucial point. The autonomous navigation system is their core product. Rekise built this using the ROS2DDS robotics framework.
Let's break that down for our listener. What exactly is ROS2DDS and why does it matter so much?
Sure, so ROS2 stands for Robot Operating System, and DDS is Data Distribution Service.
Okay.
Think of it as the ultimate universal translator for hardware. In legacy defense platforms, the software was highly customized and rigidly hard-coded to a specific sensor.
So it wasn't flexible.
Not at all.
Yeah.
If you wanted to upgrade a camera, you practically had to rewrite the entire submarine's software architecture. ROS2DDS completely changes that.
Oh, I see. So instead of a rigid, custom-built machine, it's more like a Lego baseplate. Like the baseplate, the operating system is the permanent foundation.
Yes, perfect analogy.
And if someone invents a far more advanced passive sonar array 5 years from now, you don't have to melt down the submarine or rewrite millions of lines of code. You just snap the new sensor onto the existing board, and the software instantly knows how to communicate with it.
Exactly. It creates a modular, future-proof architecture. It's just like buying a smartphone. The metal and glass are cool, but the operating system is what actually makes it smart. And more importantly, it is a single sovereign software code base. Rekise uses this exact same foundational code to run their autonomous surface vessels, the boats operating on top of the water, as well as their underwater vehicles like Jalcopy.
Which circles perfectly back to our earlier point about data sovereignty. Because this modular code is written in India by an Indian company, the data pipeline is entirely secure.
Completely closed loop.
Right. The acoustic signatures it logs, the topography it maps, none of it is ever processed through a foreign algorithm.
And the intelligence value of that closed loop just cannot be overstated. But there's another thing. The true game changer unlocked by this software framework is the capability for swarming.
Swarming. Like a coordinated fleet acting together.
Exactly.
But wait, hold on. I'm seeing a massive contradiction here.
What's that?
You mentioned earlier that Jalkapi operates deep underwater, and water absorbs radio frequencies.
Yes, it does.
There is no Wi-Fi, no GPS, no cellular data down there. If they can't broadcast a radio signal, how do multiple drones talk to each other to actually swarm?
That is the defining challenge of underwater autonomy. You cannot use the electromagnetic spectrum. Instead, they use acoustic modems.
Acoustic modems.
Yeah, the vehicles communicate by sending sound pulses through the water. Essentially, they are translating binary data into complex acoustic pings. It's actually somewhat similar to how marine mammals communicate over vast distances.
Wow. So they are effectively chirping at each other in the dark.
Precisely. Now, it is extremely low bandwidth compared to, say, a surface Wi-Fi connection. You cannot stream high-definition video between them.
Right, it's just basic data.
Exactly. You can only send tiny packets of critical data, like anomaly detected at these coordinates, move to intercept.
So the local autonomy engine on each individual sub has to be smart enough to take that tiny piece of acoustic data and translate it into a complex navigational maneuver.
Yes.
Without waiting for human confirmation.
That's the swarming behavior in action.
That level of AI sophistication is just staggering, which honestly forces me to look at the financial realities here.
Oh, the financials are wild.
Building a 20-ton robotic submarine with advanced acoustic swarming AI sounds like a project that requires a massive, multi-billion-dollar defense prime contractor. You know, companies with sprawling corporate campuses and limitless budgets.
Right. The usual suspects.
But Rekise is a startup. How are they pulling this off?
It is a masterclass in frugal defense engineering. The traditional defense prime contractor model is just notoriously bloated. When a prime takes on a project like this, they often build bespoke shipyards, hire thousands of administrators, and bake enormous overhead into the final price tag.
The numbers in our notes are almost unbelievable. Rekise has only raised about $4.7 million across 2 rounds.
From 27 investors, yeah.
Less than $5 million.
Yeah.
And the founders have retained 64% ownership, which is practically unheard of in deep tech. Usually, capital needs dilute founders into the single digits very quickly.
It really is rare. And to put that in a global perspective, look at the United States Navy's equivalent program, the Boeing Orca program.
How much was that?
That program consumed roughly $620 million. Wow.
Yeah. And Rekise is attempting to place India into a very exclusive club of nations. There are fewer than a half dozen globally, including Australia, with their Anduril Ghost Shark, and China, with their HSU-001 that are building extra-large unmanned submarines. And Rekise is doing it for a fraction of the cost.
But how? I mean, you can't just wish away the cost of forging 20 tons of pressure-resistant steel. Where is the actual cost savings coming from?
It comes from a highly strategic division of labor. Rekise realized they didn't need to build a shipyard from scratch just to build a submarine.
Right.
They focused entirely on their core competency, which is the autonomy, the sensor integration, the ROS2 framework, the brain.
And for the body.
For the physical body, the steel hull. They partnered with KDAL, Krishna Defense, and Allied Industries, located in Gujarat.
Okay, so KDL essentially acts as a highly specialized 3D printer for Rekise's software brain.
That is a brilliant way to frame it. Because they already have the foundries, the specialized welding equipment needed for high-tensile steel, the heavy cranes, KDAL takes the physical manufacturing execution, while Rekise focuses on the intellectual property.
Exactly. And they actually started cutting the steel plates for Jalkapi in June of 2025. By decoupling the software development from the heavy manufacturing, Rekise stays incredibly lean.
Because they don't have a shipyard sitting idle.
Right. They don't have to pay the overhead of a massive shipyard when they aren't actively cutting steel. Furthermore, they aren't guessing what the military wants. The Indian Navy's own submarine design group is providing the exact specifications.
And Rekise proved the viability of this model by winning the Indian Navy's IDEX 8AI TI 1.0 challenge.
Yeah.
Let's clarify what that challenge is, because it's not just a casual grant application, is it?
Not at all. The ADITI 1.0 challenge is a grueling, highly technical vetting process run by the Ministry of Defense. Startups are subjected to intense scrutiny by naval engineers.
So winning it is a big deal.
It's huge. Beating out established prime contractors to win that challenge signaled to the entire industry that Rekise's software architecture was legitimately viable for military deployment.
Okay, I love the underdog story of a lean startup taking on the defense giants. But I have to push back here.
Fair enough.
We're talking about a startup that raised under $5 million. Boeing spent $620 million.
Mm.
We have to ask, is this a true triumph of frugal engineering? Or are they dangerously undercapitalized the second this thing touches actual salt water?
That is the real test.
I mean, building a software simulation in a lab is one thing, but putting 20 tons of steel into the Indian Ocean is completely different.
That is the most critical question to ask. And the honest answer is that we will not know for sure until Jalkapi undergoes extensive sea trials.
Which are happening when?
They are scheduled for around 2026 or 2027. And you're right, the ocean is the ultimate unforgiving judge of any engineering project.
Because nature actively tries to destroy anything you put in the sea. And you mentioned biofouling earlier in our notes.
Yes, biofouling is a relentless problem. Autonomy that works in harbor trials often fails in the open ocean. Barnacles, algae, and marine life will aggressively grow over delicate camera lenses. They'll clog mechanical valves and cover sonar arrays.
So your sensors just stop working.
Right. A sensor suite that works perfectly during a test in calm, relatively clean water can be rendered completely blind by biofouling after a month in the open ocean.
Not to mention the sheer physical force of the ocean. You have fierce, unpredictable thermal currents that can easily grab a 20-ton vehicle and throw it miles off course.
Exactly.
And the autonomy software has to constantly correct for those physical forces, all while dealing with the underwater communication blackouts we discussed.
The hardware and software integration will be pushed to the absolute limit. But, beyond the physical dangers of the ocean, Rekise also faces a severe business risk. In the defense industry, it's notorious. It's known as the procurement valley of death.
The Valley of Death. Break that down for us. Why do so many defense startups die there?
So the Valley of Death refers to this agonizing gap between a successful prototype and an actual scaled production contract.
The waiting period.
Right. A startup like Rekise might successfully build Jalkapi. They might put it in the ocean, pass the sea trials, and get a standing ovation from the Navy. But the military procurement cycle moves at a glacial pace.
So they don't get paid right away.
Far from it. It can easily take 3 to 5 years of administrative reviews, budget approvals, and committee meetings before the Navy actually signs a contract to purchase, say, a fleet of 20 submarines.
And if you've only raised $4.7 million, you simply do not have the financial runway to keep your engineers on payroll while you wait 3 years for a government purchase order to clear.
Exactly.
You just bleed cash, and the company dies before the product ever reaches the fleet.
The history of defense innovation is literally littered with brilliant startups that built revolutionary technology but starved to death waiting for a purchase order. Prime contractors survive this valley because they have multi-decade, multi-billion-dollar maintenance contracts that provide steady cash flow.
So cushion.
Right, but a startup has no such safety net. Now, there are progressive initiatives like IDEX trying to grease the wheels of procurement, but changing how a massive bureaucracy buys submarines takes time.
So they'll probably need more money.
Rekise will almost certainly need to raise substantially more capital to survive that transition from building a single prototype to manufacturing a full squadron. Their current capital efficiency is heroic, but relying on it indefinitely is dangerous.
Which means watching their progress over the next couple of years is going to be absolutely fascinating. It's a high-stakes tightrope walk over the Valley of Death.
It really is.
But if we zoom out from the mechanics of Jalkapi for a second, our sources point to a broader trend here. This isn't just a story about one submarine, is it?
No, it's part of a much larger, sweeping autonomy thesis playing out across the globe right now. We are witnessing these agile startups claiming sovereign capabilities in domains that, historically, belonged exclusively to massive nation-states with unlimited budgets.
Right, like space. We see startups 3D printing rockets to ensure sovereign access to low Earth orbit.
Exactly. Or networks. Startups securing quantum communications. Or even low-altitude skies, with commercial firms building autonomous drone swarms.
And Rekise Marine is executing the exact same thesis just in the deep ocean.
Yes. It represents a full vertical stack of national sovereignty. You secure your data networks, you secure your orbital assets, you secure your airspace, and now you secure the deep waters.
So the requirement for sovereign technology holds true at every altitude, including the negative ones.
Beautifully put, yes.
So what does this all mean for you, the listener? The core takeaway here is that Rekise Marine is taking on one of the most punishing engineering environments on the planet, and they're doing it by leveraging smart software, frugal engineering, and strategic government partnerships.
Right. by separating the brain from the body.
keeping that complex ROS2 software in-house while partnering with legacy shipyards for the heavy steelwork. They're attempting to deliver an unblinking robotic eye for the Indian Navy at a fraction of the traditional cost.
They're essentially proving that maritime supremacy in the 21st century might not belong to the nation with the biggest shipyards
But to the nation with the smartest code.
and the most resilient data architecture.
Exactly. And if they pull this off, they deliver strategic independence in a region where dependency is simply not an option. Which brings me to a final thought I want to leave you with today. The Indian Ocean carries roughly 80% of the world's seaborne oil trade right past India's doorstep, every single day.
It's massive.
It is the undisputed lifeblood of the global economy. And beneath those waves, an invisible, quiet contest is already underway. They are mapping the thermoclines, logging the acoustic signatures, and preparing the battle space. When the deep ocean inevitably becomes the decisive theater of conflict in the decades to come, will your country be watching with its own eyes or borrowing someone else's?